Hey guys, this is Miss Delich. I am going to make a quick little video to go over some of the addition strategies that we have learned. As the numbers get larger in second grade, it can be difficult to keep all of the strategies apart and know which is which. And I learned to add numbers by stacking them, like 17 and 34, as I'm sure many other adults did. However, this is not what we use to teach kids today. They will use this method. We call this the standard algorithm, where we stack them vertically on top of each other. They will use this further down the road. I want to say 4th, 5th grade is when it's developmentally appropriate for them to start doing it this way. However, in second grade, that they're not ready for that. That is not appropriate for them to be adding. And the reason for that is because they're not understanding what's happening with the place value. They're just doing a process. They're carrying the one. They're not truly understanding what's happening with those numbers. So that is the reason for not stacking. You might hear your kiddo say, oh, we're not supposed to do that. Well, that is why. So the first strategy I'm going to go over, there are 5. This first one is an open number line. And an open number line is just like an empty number line. And let's say our equation is 47 plus 25. Okay? They're going to pick their first addend and put it at the beginning of their number line. And then 25, the second addend, the number that they're adding, they're going to represent in jumps. Okay? You could do 2 jumps of 10 or 1 large jump of 20. And then you could do a jump of 5, or if they need to do those 5 tiny individual jumps of 1, they can do that as well. Okay, so 47 and 20, 67 plus the 5, that's going to give us 72. Okay, so that is the open number line. I went through that pretty fast, but that's the gist of it. The next strategy I'm going to talk about is compensation. Okay, and compensation is a strategy that can be very confusing, and if it doesn't make sense to a kiddo, they just might not be ready for it just yet. But that doesn't mean that they can't utilize it further down the road. So compensation is basically just making it easier to add. So if we had, let's say, 49 and 16, okay? Looking at an equation, if you have one of your addends that's really close to a friendly tens number, so for example, 49 is really close to 50, okay? And so then we would prompt the students, okay, well, how much does it need to get to that friendly tens number? Okay, well, it just needs 1, and then it'll become 50. Well, if I'm adding 1 to this, I have to take it away from my second addend. Okay, so 16, take away 1, is going to be 15. And so now I have this new clean equation of 50 plus 15. It makes the numbers a little bit cleaner, a little bit easier and friendlier to work with. So compensation is just making numbers easier to add by compensating, taking something from one number and giving it to the other to get it to a friendly tens number. And then that's a much simpler, cleaner equation. All right, our third strategy is partial sums. And partial sums is where we are going to really look at the place value and look at the digits and what place they're in, and utilize expanded form along the way. So 32 is broken up into 30 and 2. 27 is 20 and 7. Okay, and we're going to start by figuring out part of our sum. Okay, 30 and 20. 50. Okay, I've done that part of my sum. Now I have to do the other part of my total sum, which is going to be 2 and 7. And that's 9. So I have 50 and 9. That's a part of my sum, and that's a part of my sum. Well, I have to add those together. So I'm going to do 50 and 9, and that will give me my answer, 59. Okay, this strategy works for addition. However, with subtraction is when it's going to be tricky, because students will want to break it up just like so, but then if, you know, this was 32 minus 27 per se, they can't just do 2 minus the 7. They're not going to have enough. So that's, you know, something to keep in mind about this strategy and breaking them all up like that. But the strategy I'm about to show is a great alternative if your student likes to really break up the numbers. So this next strategy is called break apart, and it is a very simple, very solid strategy to rely on. So if our equation is 52 plus 39, okay, break apart is where we are only breaking up the second addend. We are keeping 52 as is, and we are going to break up the second addend, 39, into expanded form, 30 and 9. And then I'm going to add the pieces as they come. So 52 plus 30. Okay, and they should be able to add on those 10s and come up with 82. Okay, now all that's left is this 9. Okay, so 82 plus 9. And for some students, they may be very intimidated by adding that, because you're going to regroup your ones, you're going to go up to the next tens place, it might be confusing. So I've encouraged students to even break up the ones even further. Well, I could break up this 9 into 8 and 1. And instead of just adding that 9 all together, because that's confusing for me, I can just add the 8. And I know that's going to give me a nice clean tens number. And then all I've got to do is just add that 1. And that is only if it's needed for your student. If they need to break it up and take that extra step, they are welcome to do that. It's whatever works best for them, whatever helps them. If they don't need to do that, great, more power to you. So then 91. Okay, that's our fourth strategy, break apart. I apologize, I'm going kind of fast. I just don't want this to be a super long video, but I did kind of want to just show a lot of the different strategies because I think it'll be helpful for us to all be on the same page. So then our last strategy is going to be place value, which we also call base 10. Place value, base 10 blocks, same thing. Okay, and I'm showing this last because as students get older, they're going to be working with much larger numbers, and they can't always rely on drawing out all of these blocks. You know, it's still appropriate at this age, but we really want to encourage them to try to use a different strategy, something that's more efficient, something that's not going to take as much time as drawing every single block and crossing out and doing all of that. If they still really need it, then that's okay. They can resort to that. But if they can use one of the previous 4 strategies I've shown, or if they can even do mental math, that's great. But we want to try to encourage them to stray away from that. So if I have 31 and I'm adding 47, so of course they're going to draw 31 with base 10 blocks. And we show them that these rods, these are our tens rods, they each represent 10. Okay, so then, you know, I can label, that's 30, and I have 1. Okay, and then I'm adding 47. So I have my 4 tens rods, each rod represents 10. And then I have my 7 ones, okay? And we encourage them to look at your place value, 30 and 40, and that is going to give me 70. And then I have 7 and 1, and I know 7 and 1 makes 8. So then I have 70 and 8. okay? And you might be thinking, well, a lot of the other strategies seem like just as much work, which is true. However, you know, towards the end of the year, we're going to start working with 3-digit plus 3-digit numbers, and it's just not practical for them to continue to be drawing these blocks. And if they can demonstrate understanding of a different strategy that's not using those concrete visuals right here, if they can start to think more abstractly of the numbers, that is key. That's really what we want. So I know I went kind of fast. I hope that this made sense. I hope that this was helpful. But these are the 5 different strategies that we have taught students so far this year in 2nd grade for adding numbers. So thank you so much, and let your teacher know if you have any questions.